Alright, so here's the solution to problem 1 from the ideal gas law group activity. So the setup is that you have 3 bulbs that are closed off from each other. Helium is in a 1 liter bulb at a pressure of 200 torr. We have neon also in a 1 liter bulb at 410 torr, and argon in a 2 liter bulb at 250 torr. And the question asked to calculate the final partial pressure of each gas when all these are opened together and what the final total pressure is going to be. So the idea is that when you open up these containers to each other, this becomes one large container with a volume of 4 liters, and the gases just mix together. So you might be tempted to start off thinking, I need to calculate the actual amount of each gas that I have. And so you would say, well, you would start with the ideal gas law, and solve for n like this, and it's equal to the pressure and the volume times RT, and then quickly stumble because I didn't tell you the temperature. I didn't mean to, but you do know that it's constant. So you need to think about this just a little bit differently. So consider for any one gas, let's say helium. So what we can say is that the initial pressure, which I'll just call pressure 1, and the initial volume of helium is equal to, according to the ideal gas law, N times R times T. And this would be N helium as well. But after you've opened them together, pressure 2 of helium times the new total volume is also going to be equal to the number of moles of helium times R times T. So if both of these are equal to the amount of helium times RT, then they have to be equal to each other. So you have an expression saying that the initial pressure of helium times the initial volume of helium is just equal to the final partial pressure of helium times the total volume. And in this case, at this point, just solve for the final pressure of helium, and that's just going to be equal to its initial pressure times its initial volume divided by the total volume at the end. And in this case, just plug in numbers. So we have 200 torr times 1 liter divided by 4 liters. And that gives us 50 torr. And that corresponds to about 0.065 atmospheres. So if you do the same thing for the neon, you get a pressure of 102.5 torr. And for argon, 125 torr. So those are your answers for 1A. And 1B, the total pressure is just going to be the partial pressure of the 3 components added together. So the partial pressure of the helium plus the partial pressure of the neon plus the partial pressure of the argon. And that adds up to 277.5 torr, or 0.365 atmospheres. And that's the answer to problem 1.